Good morning, Trig. We're going to jump into lesson 48. Hopefully I finish this before our study guide review because that's important. All right, so powers of trig functions is 48.A. So powers of trig functions refers to like sine squared. So I need to go over how that is written. So for example, do I write sine of theta squared? Is it written sine of theta squared, or is it written sine of squared and then theta? So it talks about all the different ways to write it. So the first thing, these are three ways, but this one is never used. It's improper because you're not squaring the angle. Okay, you're not going 60 degrees squared because that'd be 3,600 degrees. So we're not doing that. This next one is also not used. You'll never see this in the book. It is proper, but it's not used. This is the one that you will see in the book. And so know that your power is going to be above the sine. So for example, it could be written the cotangent cubed of, I said cube, but or the cosecant cubed of x. Okay, so notice where the degree is written. It's written before theta or x. Okay, so that's just how it's written, and that's how it should be properly written for us. So we're going to practice a couple. So number one, now for all of these, we are going to evaluate without a calculator. I should not see any decimals in your work when it comes to trig functions. It should be based on your reference triangles, and it should be based on a drawing. So first things first, I'm going to draw those reference triangles on the side. So here's 30, right? That means this is 60. We should always draw these 1, 2, root 3. And then you should have your 45, 45. And it's 1, 1, root 2. All right, so here we go. Number one, evaluate. That's what we're going to use for all of them. Evaluate the sine cubed of negative 60 degrees. So we're going to start small. Okay, so the first thing we're going to do is I'm going to draw a picture. Okay, so negative 60 degrees. Remember, we always start on the x-axis. Negative 60 would mean that I am moving clockwise. 60 degrees. So I have, and I should redraw this. So I went 60 degrees, and I went negative. So this is 1, this is 2, this side over here would be root 3, right? Because I'm looking at the 60 degree. So I'm first going to keep this out here. My bad. So the sine of 60, don't worry about the third, would be opposite. So root 3 over, right, should be opposite over hypotenuse, which in this case the hypotenuse is 2. But I'm in quadrant 4. All students take calculus, so I am negative. Now I'm going to raise the power. So number 2, raise side ratio by power. Okay, so I am cubing this, right? This is to the third. So I have negative root 3 to the third over 2 to the third, right? So negative root 3 times negative root 3 times negative root 3, right? This would give me positive 3. This would give me negative root 3. So I get negative 3 root 3 over 2 times 2 times 2, which is 8. Okay? Next one. We're going to do more complicated ones. Evaluate the cotangent squared of 330 degrees. For some reason, the book always puts the negative degrees in parentheses, and your positive aren't. Okay, so first we're going to draw a picture, right? 330 would be clockwise. There's 180, 270, 330 would be all the way to here. So 360, I almost went 360 minus 330 means I'm evaluating 30 degrees. So I'm actually evaluating the cotangent squared of 30 degrees. Now remember, cotangent is the reciprocal of tangent. So tangent, this is 30 degrees. So this is 1 and root 3. So the tangent of 30 degrees would be 1 over root 3. But because I'm in quadrant 4, I know I'm negative. So the cotangent of 30 degrees is the reciprocal, negative root 3 over 1. So this equals negative root 3 over 1. Now I raise the power. So first find your side ratio, then we will raise the power. So this gives me, right, negative root 3 times negative root 3, and I don't need the over 1, so that would give me a positive 3. So the answer's 3. All right, so now we're going to move on to more complicated ones where we're going to have more than one to evaluate. So number 3, evaluate the cosecant squared of negative 405 degrees minus tangent squared of 45 degrees. So I'm going to kind of do both so you can see both. So first of all, 405 minus 360 is 45 degrees. So I'm going to go a full circle, so I'm going to draw a picture. It's negative, so I'm going clockwise. So there's 360. Then I'm going to go 45 degrees. So I'm down here. Okay, so I'm actually evaluating cosecant of 45 degrees. I will square it later. Cosecant is the reciprocal of sine. So the sine of 45 degrees, right, is I have 1 root 2. So it would be 1 over root 2. Cosecant is the reciprocal, so root 2 over 1. I'm in quadrant 4. All students take calculus, so it's going to be negative. So this produced a negative root 2 over 1 squared. Okay? Now the tangent of 45. So this, and I'm going to bring down this minus sign. The tangent of 45, right, is right here. 1 root 2. 45 is opposite over adjacent, and everything's positive here. So this is 1 over 1, and now I'll square it. All right, so here we go. This becomes negative root 2 squared is just 2, right? Because negative root 2 times negative root 2. And then minus 1 over 1 squared is 1. So my answer is 1. Next one. So let's go. We haven't done one in radiance in a long time. So we're going to, all of these should say evaluate. And remember, I'm trying to do this before our study guide review. Evaluate secant squared of negative 3 pi over 4 plus cotangent squared of 7 pi over 6. So first things first, convert to degrees, remembering that pi is 180. So using my calculator, negative 3 times 180, right? That's what this says. And order of operations, it'll do it for me. So this is secant squared of negative 135 degrees plus This is cotangent squared of, whoops, I don't need that big of parentheses. Now I'm going to convert this second one. So 7 times 180 divided by 6. And so I get the cotangent of 210 degrees. Okay, so now the second thing is, that's 1. 2, draw pictures. Okay, and I'm going to use reference triangles. So negative 135 would be clockwise, and it wouldn't be to 180, it'd be here. 180 minus 135 is 45 degrees. So I'm actually evaluating the secant of 45 degrees. Secant, though, is the reciprocal of the cosine of 45 degrees. So that's what I'm evaluating. That's 1 root 2. Cosine is 1 over root 2, so the reciprocal would be root 2 over 1. Okay, then I have to talk about all students take calculus, so I know I'm negative. So I end up with a negative root 2 over 1 squared, or you could just write that as negative root 2 squared, right? You don't need the over 1. So that is, I've evaluated this guy. Okay, then I'm going to bring down the plus sign, right, because this was an addition problem from the very beginning. So that is why there is a plus sign there. Now I'm going to draw this one. Positive 210 would be 180, 210. 210 minus 180 is 30 degrees. So I'm actually evaluating the cotangent of 30 degrees, but I look at who my reciprocal is. My reciprocal is tangent. So the tangent of 30, right, short leg, hypotenuse, root 3. That would be opposite over adjacent. So the cotangent of 30 degrees is the opposite, right, is the reciprocal. So I'm flipping that over. Also, this is all students take, so I know I'm positive. So I'm going to put, this would be root 3 over 1 squared. So I'm just going to write root 3 squared, right? I don't need the over 1. So this is negative root 2 times negative root 2, so that would give me a positive 2. Root 3 times root 3 is 3, and I'm adding. So my answer is 5. All right, if you were here, I would ask you if you need more examples, but you're not here. So here we go to the next part of our notes. So 48b is a review from geometry. We are going to algebraically find the perpendicular bisector. And we are going to use only one method. We're going to use the midpoint. You can ignore the other one, midpoint method. If you want to use the other one, you have to look it up in the book, but I don't care what the book, like if they say use this method, ignore it. Just use this method, it's the easiest. So the midpoint method means that I'm first going to calculate the slope. Hopefully I don't need to review, but I will. Slope is the difference in your y's divided by the difference in your x. 2 is I'm going to find the perpendicular slope. Hopefully you know that this means perpendicular. It's just the symbol because the actual word takes forever to write. 3 is I'll calculate midpoint, which we did go over in a prior section, but x equals your x values divided by 2, y equals your y values divided by 2. And 4, use midpoint and your perpendicular slope in your point slope form. Y minus y1 equals m times x minus x1. So I'm going to do 2 examples. I think that's all you're going to need. But these are your These are your steps. So jumping into, I think the last example we did was number 4. So find, in the direction, find equation of the perpendicular bisector of the line whose endpoints are, and so I'm going to do part A. If these are my endpoints, 4, 2, 8, -3. All right, so step 1 was to calculate slope. Step 1, slope. So my y value is -3 minus 2. My x value is 8 minus 4. That gives me -5 over +4. If this is my slope, step 2 is to find my perpendicular slope, which would be the opposite. So if it's negative, positive, reciprocal. So I'm going to highlight. I'm going to use this later. Step 3 is to calculate my midpoint. So x equals the sum of my x values divided by 2. So 12 over 2 equals 6. And y, the sum of my y values, so 2 plus -3 divided by 2. That gives me -1/2. So my midpoint is 6, -1/2. Step 4 is to use point slope form to find my line. So here's point slope form. I've highlighted what we're plugging in. Here's the m, there's my perpendicular slope, and my point, I'm going to plug in x and y. So y minus -0.5 equals 4/5 times x minus 6. Okay. So I'm going to simplify this. I'm actually, you know what, I should probably, since I have a fraction over here, keep this as 1 over 2. So this leaves me with y plus 1/2 equals 4/5 x, right, I'm distributing, minus 24 over 5, right, this is over 1. 4 times 6 is 24. And then I would have to subtract 1/2. So common denominator between these two would be 10. So that would give me 5 over 10 and I'd have to 48 over 10. So y equals 4/5 x minus 53 over 10. Okay. We'll do one more, and that will complete our notes. So here are my endpoints, -2, -3, and 4, 3. And this time we're going to write our answer in general form. Now remember, general form means I'm going to write ax plus by plus c equals 0. Okay? So first step is to find slope. So 3 minus -3 over 4 minus a -2. That would give me 6 over 6, which equals 1. Step 2 is to find my perpendicular slope, which would be opposite reciprocal, because 1 over 1 is just 1. Okay, and remember, I'm going to use this later. Step 3 is to calculate our, whoops, this should have an m next to it, midpoint. X equals -2 plus 4 divided by 2, which is 1. And y equals -3 plus 3 over 2, which equals 0. So my midpoint is 1, 0. So there's my x and y value. And I'm going to use these two pieces of information in point slope form. And then at the end, I'll put it in general form. So y minus my y value equals my slope times x minus my x value. And sorry, my screen timed out. So y equals negative x plus 1. Now it wants it in general form. So x plus y minus 1 equals 0, right? I just added x to both sides and subtracted 1. You could also write 0 equals negative x minus y plus 1. So either one of these would be correct. All right, so homework for 48. Skip number 5, 18, 20, 28, 30, and number 4. I left that off. Also, you should know that for number 11, write answer in general form. I think it asks for something else. Ignore it.